Alright guys, talking about antimatter. What is it and why is it important to you? So basically antimatter is different than dark matter. We'll have a separate video for that. And antimatter is not really the opposite of matter, even though anti is usually meaning like opposite. Um, Antimatter has the opposite charges of regular matter, but it still has regular mass. So in other words, you know that basically like regular mass or regular matter that we observe all around us has mass, and in that mass are protons, neutrons, and electrons. And the protons and electrons both have a charge. Electrons are negative, no, protons are positive. In antimatter, the antimatter itself is composed of the same mass, but the particles, the protons and electrons, have the opposite charge. So the protons are negative and the electrons are positive. And so, for example, electrons, we call them positrons. You might have heard of like positron emission tomography in medicine. That's kind of where that term comes from. The positron is basically just the opposite charge. So what does that actually do for us, or what's so special about that? Basically, it's antimatter itself is extremely rare. Why? Because when it collides with matter, it automatically bursts into energy. All the mass is converted directly into energy. This is different than like nuclear fission or fusion, where only a very small percentage of the total mass is converted into energy. This is like the whole deal. Like in completely all the antimatter mass and all the matter's mass is completely converted into energy. That's really important because ultimately that would be like the ultimate fuel source. If you had a textbook of antimatter and a textbook of regular matter and put them together, that'd be enough energy to get a space shuttle into space. So you can see why having a little bit of mass can get you a ton of energy. That's what the E equals mc squared formula represents. E energy, M mass, C is speed of light squared. So a little bit of mass gives you a lot of energy. So why is this important? Why is antimatter important to you? Basically, the best way to put it is it helps us explain the beginning of the universe. A lot of people ask like, why wasn't there enough antimatter to was antimatter and matter like equal in terms of the amount in the universe? And if not, why was there an imbalance? Because you think like if you had equal amount of antimatter and equal amount of matter at the beginning, that basically when the Big Bang started, the matter and the antimatter would collide with each other. And then because of that, you would have just complete energy in the universe and not matter. But it seems like matter won out. Like there was much more matter than antimatter, which is why we are here today. So that's why this is really important. A, it could be an ultimate energy fuel source for like different spaceships and stuff, maybe like 50, 100 years from now. But also at the same time, it helps us understand the beginning of the universe as well. All right, guys, thanks again. Check out more videos.